Welcome to our session. Where's the projector? So, we're going to talk about improving student and income planning at the University of Nottingham using Alteryx, of course. So my name is Neil Davidson, and I'm here with my colleagues James Story and Jenny Holland. And so we are. So, as I said, I'm Neil Davidson. I've been working in strategy, planning and performance at the University of Nottingham for about 13 years. We've been using Alteryx in the planning department since 2015. James joined planning about 4 years ago and started using Alteryx straight away. Sorry, as soon as we got Alteryx. Jenny is a veritable newcomer to the planning team, however, has been using Alteryx for years in her previous roles, so she came in with a whole bunch of Alteryx experience. So what do we do in planning? I should have a show of hands. How many people from HE are there here, just so I can sort of gauge the smattering? Okay, excellent. So we're a fairly typical planning department, covering a lot of student analytics. We use Tableau for our reporting. We do a lot of the statutory reporting, so to the government in effect. Surveys are everywhere, so we do a lot of survey analysis. We get involved in the risk register, we get involved in strategic planning, and of course we do student number planning and income forecasting. And we're also very lucky in that we are based in that pretty splendid building, at least we are today. When we get back to the office, we're moving to a much less pleasant building, but hey-ho. So here's our agenda. So I've got a problem, and because I'm the manager, I get to delegate it to someone else. So I pass that problem on to James, and then, as James will explain, things change and it becomes someone else's problem. So then Jenny has a problem. And then we'll cover a little bit how we're using Alteryx at the University of Nottingham, because we've been advocates for it, and it's grown a little bit across the university. So my problem is that I need a robust and efficient student number planning model, so we can forecast how many students we're going to get, what they're going to do, and how much income we're going to get for them, so we can tell finance how much money we've got. There's a few people from HE here. Did anyone, show of hands of who's been through a university degree, who knows roughly about how universities work? Excellent. Although I'm not that surprised, it's an Alteryx conference, we're all smart people. And anyone study at Nottingham? Yay. Okay. Oh, excellent. Right, I may come back to you shortly. Right, so student number planning. So prediction is very difficult, especially if it's about the future, said Niels Bohr, a Danish physicist, in 1922. And when I was digging around for a quote for a slide, I also came across another one which said something along the lines of prediction is about forecasting what's going to happen in the future and then spending all your time explaining to everyone why it didn't happen. But of course, we use Alteryx, so that doesn't happen at Nottingham. We get it spot on, honestly. So what is student number planning? I'm going to stop looking at this one. I'm going to move over here now. So my boss always assures me that student number planning is very easy, fundamentally. So it's all about how many students have we currently got, and of those, how many of them are coming back. So there's our student population, and they're the ones that are coming back. So the guys that have disappeared, they've graduated, or they've left, or transferred to another institution, amazingly. So how many are coming back? And then we need to know how many new students we're going to get. Again, that must be fairly straightforward. So I'm guessing you probably worked out what these red people are going to do. They're going to move over, and they're going to join our student body of our forecast population. We just keep on repeating that for how many years. We forecast 5 years into the future. But then once they're here, we need to know what they're going to be studying. And we have a bunch of academic departments, so they get split up into departments. And then it gets a little bit more interesting because we've got some students. Does this work? No. We've got some students who are split across economics and politics, so there's a bit of shared provision there. So we need to know what they're going to do, and then we need to know how much we charge them. But again, we're invoicing them, so we know how much we're going to charge them for the courses and any other money we get for them. So it should all be fairly straightforward, yeah? There's the 4 questions. How many students have we got? How many are coming back? How many new ones are we going to get? What are they going to do when they're here? And how much income is there for them? So what fee are we going to charge them? Easy? Well, if it was so easy, I'm guessing we probably wouldn't need an Alteryx model to do it. So why is it all so complicated? So how many students do we have? Okay, that is fairly straightforward. We know how many students we've got. How many are coming back? starts to get a little bit more interesting because students don't really behave in the way you'd want them to. So this example here is a student on English. They're here for 3 years, really simple. They're split between home and overseas students, but it is all really straightforward. Medicine courses start to get a little bit more complicated. Well, they're here for 5 years for starters. Again, it's undergraduate. They're split between home and overseas, but this time we've got these direct entrants coming in. So it's starting. We've got students who come in who start their studies in another country. I think we get students coming in from Bahrain and from Kuwait, but then they join our course halfway through, so they just appear out of nowhere. So we need to start understanding what they're going to do. Architecture students gets even more complicated. So it takes 7 years to become a qualified architect. This is undergraduate stuff. They're all split between home and overseas, but you have to go out on placements when you're in the architects course. So you start, and then you go out, and then you come back, and then you join another course, and you do something else, and then you go out for another placement, maybe you can come back. So there's all that in and out, and it starts to get a bit trickier how to know how many students are coming back. And how many new students we're going to get? Well, we're going to teach them. We must know what we're planning for. There's our 3 students, and if it was just 3, it would be fairly straightforward. But we've got undergraduate courses, we've got postgraduate talk courses, we've got research courses, we've got home and EU full-time students, we've got home and EU part-time students, we've got overseas students, and we know that all these students are behaving differently depending on what course they're doing, and we've got over 800 courses, so we need to collect a huge amount of data to know what we're planning on teaching in the following year. So it's a lot of data we have to collect at the right level to allow us to model correctly. And why is it so complicated with fancy graphics? So we looked earlier at the students who, we've got math students, and we've got economics students, and we've got physics students. So this is a representation of our student modules, the modules the students take. It's a fancy core diagram built in D3 by James, which is looking at all the modules our students take and grouping the students up into, so in this case we've got a bunch of students on maths courses, and those students on maths courses are taking modules taught by different departments. So they're going off and they're doing economics, they're going off and doing physics, they're going off and doing engineering, and of course economics and physics and engineering want paying for the teaching they're doing, so we need to know what the students are doing so we can give them the money. So we have around about 200,000 different module choices every year, broken down to the nth degree. So we're crunching it gets complicated. How much income is there for them? Again, it seems fairly straightforward. Most students pay £9,000. Well, that was a couple of years ago they paid £9,000. Now they pay £9,250. Next year, who knows, or the year after when the fees review's through, and who knows what they'll be paying. So we break students into different groups depending on the fees they're paying. At Nottingham, we make things difficult for ourselves further because overseas students, well, they pay different amounts depending on what course they're on and when they started. So if a student started 3 years ago paying £15,000, they'll pay £15,000 a year. So we're just having to multiply how we're breaking all the students down. And yeah, some of the students are paying 30. That's more, £40,000 a year for some of our medicine courses for international students. So there's quite a lot of money. So easy? Well, it's suddenly gotten a whole lot more complicated. That's before you take into account strange things that happen at universities. So every university will have at least one department of Stranger Things. I know exactly who I'm thinking of when I'm saying that, who will come up with weird and wonderful models of business to try and make some money. So to stretch the Stranger Things analogy to the nth degree, they might have a joint course with the University of Indiana, Hawkins, Indiana, with some visiting lecturers from the US Department of Energy. They decide they want a new subscription-based model of £799 per month, and you have to set up all this modeling for just 11 students because that's what they like to do. Anyway, enough Stranger Things, but basically what we're saying is if you're building a model, it needs to be sophisticated enough to deal with any kind of crazy model that some school might decide they want to implement. So I think I hope I've explained why it's so complicated. And we try our best to get it right. But a couple of years ago, we weren't using Alteryx at this point. We made a mistake in our model, and we forecast our future income for year 2 or 3 of our model, and we got it wrong by about £1 million, which everyone started jumping up and down because we'd made a mistake. And £1 million is a lot of money, isn't it? So we argued, well, that's £1 million is only 0.5% of our total income, and so it's really in the noise. However, our director of finance didn't agree, so started shouting at us and wanted us to explain what was going on. So we were thinking, well, how can we get across to finance this complexity and how difficult it is? So, and the challenge being is that, yeah, we could keep it really simple, because we've only got so much time to do anything. But actually, what everyone wants is a huge level of granularity. I don't know why the Y's dropped off there. But everyone wants all this detail. And of course, when you give them all the detail, it gets harder to do. And we were like, well, is that right? Is that what you really want us to do? So we thought, well, we'll pull out some numbers for you and show you why. So shall we just give you next year's forecast income? Just give you one cell. Is that okay? Well, no, it wasn't okay. They wanted 5 years worth of income. So we added 5 forecast years, giving us 5 cells in the model. But they also wanted it breaking down by the different schools, so our different departments. So we've got about 30 different academic units, but they all want it breaking down by divisions within those units. So we end up with 56 budget units in our model. Gives us 280 cells. But they want to know how the different income streams behave, so how fees behave compared with research income, compared with whatever else we've got. So we've got 15 different income streams. We multiply that in, we get 4,000 cells. But we've already discussed how student types behave differently. So let's shove in the student types, and we've got 24 of them. And we've got 100,000 cells on our model. So Excel is beginning to creak. And then, but we've also discussed how courses are different. So we have 800 courses, 830. And now we've got 83 million cells in our model, and Excel's crashing. We need something different. And then we've also discussed how we have students going out on placement courses. And we have different, we know that students on stage 3 of a course behave differently to students on stage 2 of a course. So, and we've also discussed how architecture is 7 years long. So now we've got 585 million cells on a model. Excel's blown up. We're not far behind, and we need something different. And then finance like things to be grouped up differently. So they like us to create loads of versions. So they want us to ring fence the impact of changing fees, or the impact of changing student population, or the impact of changing intake targets. So we run 12 versions for them, and now we've got, it's all gone wrong. 7 million, I thought. Is that 7 billion? Oh, sorry. I shouldn't be doing this job, should I? 7 billion. So yeah, it's getting big and it's getting complicated. And why is it important? Very briefly, so it's a balancing act between the aspiration of what academic departments want and the reality of what they can actually deliver. So balancing student population against the income that it generates. Why is it important? So if we under-recruit, so we said we're going to get 1,000 students, we've only got 100. That school were allowed to recruit a bunch of staff to teach those students that never turned up. And as a result, timetables were created, and we have students sitting in lecture theatres on their own because there's not enough students. Our CFO, who seems to always be jumping up and down, is mad because we haven't got any money. And it's this whole quality over quantity debate which rages in HE. Do you want lots of students or do you want the best students? And of course we want both, but I'm not sure they're out there. And then if you over-recruit, so you end up with more students than you planned for, well, the reverse is true in many cases. So the schools suddenly weren't allowed to recruit another member of staff to teach the students, and they've got all these students to teach and they can't cope. So the students then can't get the seats in the lecture theatres. This obviously doesn't happen in Nottingham, because the only picture I could find was of some students sat having a chat on the stairs, not in a lecture theatre, really. And then how do students display their satisfaction with the university? Well, they then get a bad national student survey result, which impacts your league table position, et cetera, et cetera. It's the flip side of that, quantity over quality. So that's why it's important. That's why it's complicated, I think. And I talked about Excel a lot. Back in 2007, we were indeed using Excel for everything. And of course, we loved Excel because it was great, wasn't it? But we began to realize that we needed that granularity, and we couldn't get it from Excel. So this is a change from the Excel to Alteryx route, which we hear about a lot. We've got some other tools to add into the mix. So we tried Access. That didn't really work. Then someone said, why did you use IBM Cognos Enterprise Planning? That's what you need. And to be fair, it was. So we built a model in EP. We were swamped in data. Everyone's happy. I should also point out that these little flags are my sort of state of happiness with any particular tool we have at the time. So our consultants left, and we continued to develop Cognos AP. We had to rebuild it when the government changed the funding methodology for students in 2012. But we did that, it's fine. And then gradually, no, it didn't. And then James arrived, and I was like, I need a new student number planning model. James, your problem.
Right. So I joined the University of Nottingham in the summer of 2014, and my main job was to update and run the model in EP. So I had just enough time to work out how it functioned before Neil made his problem. That's me coming in. My problem. So my problem was that Neil needed a new model. It needed to be better than the old one, and so I had to build it in TM1. So why was that a problem? Well, you had a complicated model going into complex software. So the development was really slow. Even just recreating the model we already had was a chore, and I lost days of my life watching it generate rules. So I spent all my time fighting the software instead of improving our model. And then I realized that we already had the solution because we had Alteryx. So our Alteryx journey began in 2015. Neil went to a conference and he was talking to someone he'd just met, saying he had 2 really big data sets. He needed to bring them together. They had different field names. And next year, he was going to get even more data. This person happened to work for Alteryx, so they offered him a free extended trial. And as soon as we started using it, we realized we could use it for lots of things. So we do all our reporting in Tableau, and we started prepping all our data for Tableau in Alteryx. Then I built a data set with 10 years of our student data. So everything we knew about all of our students for the last 10 years, and Alteryx just handled it with ease. I even started prepping some of the data that was going into our TM1 model as it was in Alteryx. That started to spark an idea. So I eventually just thought, why not build a whole student number and income forecasting model in Alteryx? No one's ever done it before, but there's no reason you can't do it. And then I came to this conference, Inspire Europe, but in 2016, and then I became convinced that we could do it. So I built a proof of concept in about a week, which was a bare bones version of the model in Alteryx, and took it to Neil. And eventually, I convinced him that we should drop TM1 and just build the whole thing in Alteryx instead. And the advantages of doing it in Alteryx were both immediately apparent and profoundly long-lasting. So one of the things that makes Alteryx really good, obviously, is the way that you can just copy and paste sections of workflow from one project to another. You can even package them up into macros and then share them between colleagues and between projects. So it meant that when we went from a proof of concept to the main model, we didn't have to completely dump the proof of concept and start again. We could take the bits that I'd already got working, bring them in, join other sections to it. We weren't starting from scratch. Then there were a few little things that we built into our model that we really quite liked, which I'll talk about now. So one is iterations. So when we were doing it all in EP, we could really only run one iteration through because of the amount of data it could handle. Suddenly we had Alteryx, it can handle so much data. We could run multiple iterations through and even bring in all our previous ones so that we can get a great big output and see all the differences. But we wanted an automated way of just labeling up those iterations. So because we could think through the logic, we could get Alteryx to build it. So we just took some of the most frequently used, simplest Alteryx tools, combined them simply, and then got it to work. So it's really simple. It just says, if this is the first time it's running, make it iteration 1. Otherwise, find the maximum number, add a 1 to it. It's not complicated, but not having to go in and do that manually every time just makes it work. So there's a thing called default values, which is simply when we first run our model at the beginning of the cycle, we don't really have all the data we need. Someone might be planning on running a course in 2 years' time, so they put a target against it, but they haven't bothered to fill in the system how long that course is going to last. So we can't really model it. It will fall out of our model. But we still want it there when we first run it so we can get a broad picture of how it's all going to look at the end. So we use these default values. Again, using simple Alteryx tools, we just say every time it doesn't join, so where there isn't a length of course, we'll just provide a default for now. We then write, every time that happens, we write all those courses off to an output file, which comes to my next thing, which is checks. So we want to check that all the data has gone through correctly, that everything's worked. So one of those is where we've given a default value, eventually we're going to have to put the right answer in. Otherwise, our model's not going to be accurate. So we can take that output file, and it just acts like a checklist. For each of these courses, we need to know the length of them. You go, you find that out from somewhere, you put it into your model. When you run your model through and there's no longer any courses in that file, you know that you've got all the data you need. So finally, reporting. As I said, we do all our reporting in Tableau. And Alteryx makes it very easy. It writes the Tableau files as well as tons of other files. And the beauty of that for us is that from the very first day that we run our model each year, we put it out into Tableau, we get to check it, we get to visually analyze it, see how it's working. At the end of the process, months later, when we're going to give it out to finance and to the rest of our business, it's that same workbook that we then give them out. So we're not doubling our workload. We're using the correct tool to check it and to give it out to the business. Wondering when that's going. Oh yeah, right. This one always gets me. So we built our model, and Neil and I were really happy with it and ourselves, I think. But we'd built it to a deadline, and there were lots of things that could be improved by it. Sometimes you just have to get the thing done. Alteryx allows you to do that. The beauty of Alteryx is that you take simple tools and you combine them together to make complex systems. But when you have that complex finished system, you can always drill back down to the simple tools and see exactly what's happening at every stage. So if you have someone who knows Alteryx but doesn't know your model, you can give your model to them and they'll be able to know what's happening. So I'd solved my problem. Neil needed a planning model. I'd found Alteryx and built it in that. I then got moved off onto some other work, and then Jenny had a problem of her own.
Okay, so yeah. So as Neil mentioned, I'm relatively new to higher education. So beforehand, I worked at Experian. So really, my problem was that I needed to understand all of this stuff. I needed to understand how the student number planning model worked and how it actually worked in Alteryx as well. And then also, I had a problem because Neil wanted it to be even better than before. So this is where I started, and this was the planning model that was built by James. And you might think, actually, it doesn't look that complicated there. But when you consider that this one process links to another 9 additional macros, which are contained within these 2 macros, things start to get a bit more tricky, especially when the macros are even bigger than the original process itself. So this is income calculations, and this is retention rate. So this is even bigger. So you can see I've got a bit of a problem. So I need to understand what's going on. So what did I do? So because I knew Alteryx, I ran the process a few times, and I could kind of work out what was happening in the process, because I understood Alteryx and understood what it did. So I could kind of see where Neil's 4 questions fitted into the model. So we've got the current students, we've got the new students, we've got what they're studying, and we've got how much they're paying. So it's like, great, that's good, and I can understand it. But the problem was, when I was doing some other work and had to go back onto the student planning model again, I'd kind of forgotten what I'd done before, and if I had to go back and make changes, it was really difficult for me to find the sections that I needed to change. So I needed a way of making it easy for me to understand. So this is what I did. So I kind of went over the top with comment boxes in various colours. So you can see I built up the comment boxes over time. There we go. So I can see now that the purple section, which is, which is here, this deals with PGR students, but that actually wasn't so clear before. But also, it didn't stop there. So I also then started to annotate other macros as well. So this is retention rates. So that went from that to that. So you can see it's really brightly coloured. So maybe too brightly coloured, actually, but it helps to make sense of what's happening. So now I can see that actually there's grey sections of this workflow that are actually checks. So these are actually not part of the process itself. They're just checks to make sure that it's working as it's meant to. And also I can see that this section in the middle gets repeated for each forecast year. So that's a bit clearer now to me what's happening. So I'm just going to focus on this section at the bottom, just to explain why I think documentation is so important. So in this section here, we've got a little bit of the workflow. So because I could understand Alteryx, I could know what was going on. So I can see that it's got a filter, and it is filtering course A108 in year 1, and it's changing that to A100. So it's like, right, okay, I can understand that. But the problem was, because I'm kind of new to HE, I don't really know what these courses are. So it actually helps to add a bit of context to it. So actually, this course is a foundation course for medicine. So it actually helps to add a bit of context in so we can kind of understand what is happening. And also why documentation is so important is because Neil might come along and say, actually, Jenny, we need to adjust the way that we apply the OFS, which is the Office for Students income. Can you add this into Alteryx? So I was like, yeah, okay, I can add it in. And the documentation actually really helped me because I could see which bit I needed to change. And you can see here that this yellow section is the bit that I added in. So it really helped me to be able to find out the bits I needed to change. So just some documentation top tips. So you've seen that I love the comment box in various bright colours. But there's some other documentation top tips that you might not have thought of. So there's also in-tool annotations. So they're available with every single tool. And they're just there to give a short amount of annotation to each tool. So for example, add some record counts. And I find those quite helpful. Also, there's tool containers. So what you can do there is you can put sections of your workflow into a tool container, and then you can disable them. And I find that really useful when I'm putting in checks, because then I can disable my checks, and that process doesn't then run each time, and it saves time in the workflow. And also what I like to do is I like to add a number to each of my modules so I know which order I ran them in. And I think that's particularly useful when you're running something such as this. So we run this process, we ran it 12 times this year, so we need to know which order we run the modules in. And also what I like to do is I also like to add a number to my outputs as well. So any outputs that come from module 1 are also prefixed with a number 1. It just helps me to keep things organised. So the planning model, as it was great, and yeah, it was a great process, but actually we can make it even better. So I've started building next year's planning models. This is 1920 model. And I'm just going to explain a few things that we're going to do to make it even better. So firstly, what I've done is I've created some summary documentation, and this is just in PowerPoint. And I've split the process into 7 stages, and I've just explained what each of the stages does. And then this documentation can then go to other people in the university just to help them understand the complexity of what we do. And also it helps when Neil comes to me and says, actually, Jenny, we need to find out the courses that take a year out. So I can quickly and easily go to my documentation and say, oh yeah, this is the bit where that comes in, and go to my workflow, and I can find the answer and give Neil the answer in 5 minutes. Whereas before it would have taken me a long time to work through all of the workflows to work out where it was. Also, what we're trying to do is we're trying to streamline the process as well. So remove any repeating processes and centralizing data sources as well. So for example here, we've got quite a lot of text inputs that are scattered around the workflows. So for example, this one, it changes the names of budget units from one thing to another. So for example, German studies to modern languages and cultures. And this happens at various points throughout the workflow. And this is fine because things change over time and that's okay. But actually, it's kind of easy to forget that they're there. It's easy to miss them. So when you are running the process in future years, it's easy to forget to change them. So what I want to do is I want to bring all of the inputs and identify them at the start of the process so that we know what we need to change, and the process can then run without much interference from us. And finally, what we're trying to do is add some more tests and checks. So James mentioned that we already do a few checks in the process, but we can add even more into the process. So one tool that I found is a test tool. So I don't know whether you've heard of this one before, but it's kind of hidden away in the developer tab. But this is a really useful tool because it gives you an error message if one of the conditions in your test criteria is not met. So for example, if I've got two inputs that are going into a join, and if some data falls out the left side of the join, I know that I've got a potential issue maybe. I can put a test tool on the left side of the join, and it gives me an error message to tell me that that's an issue. I can go back and I can investigate that. And it's particularly good when you're building Alteryx applications as well, because the process is hidden from the user. So whose problem next? Well, I think it's all of our problems, but it could be, we could have a new person that picks it up next year. So it's really important that we make this process the best it can be. As Neil mentioned, it's a really important process. It's really important that we get these figures right. So we need to make sure that we make the process the best it can be. And I think really to sum up my section of the presentation, I'd say that Alteryx is a great tool. I really enjoy using it. I enjoy using it for problem solving, and I've used it for many years. But just don't forget about your documentation, because it's really important if you want to make your process repeatable and shareable. I know it's not the most exciting thing to do, it's not my favourite thing to do, but just don't forget about it. And also, I think once you've built a process in Alteryx, it's not the end for that process. You can go back, you can refine it, you can make it even better. It's really important for us to make this process the best it can be, so we can go back and make it even better. And I've just got a few slides about Alteryx at the University of Nottingham. So I think our team were really the pioneers of Alteryx at the university, but there's other teams that also use it too. So I asked them for some quotes, and I'm not going to read all of these out, but you can see that Keris at the top says that Alteryx has changed her life, so that's pretty good. But I think really Daniel sums it up because he says that it saves his team a significant amount of time to focus less on repetitive tasks and more about how he can add value to the services that he offers. So I think that's a really important point. And also, we've been part of the Midlands Alteryx user group too. So I hosted a couple of these at the University of Nottingham. And if you're not a member of the user group, it's a great way of meeting other local Alteryx users, sharing tips and tricks and best practices, use cases. You might get some free pizza as well, some Alteryx swag, and you can see that our pets at the side, they like the pet bandanas. So it's just a good social evening, so I recommend joining an Alteryx user group. So now I'm going to pass back to Neil, who is going to take you through some top tips about building an existing process in Alteryx. Okay.
So we've done this session a few times before. You may not think that, but we have. I think a lot of HE institutions that we've spoken to have been quite interested in what we're doing in Alteryx. So last time we did this, we put this together. So I'm just going to run through it. I think you kind of need to know what you're doing. So you need to know and understand your existing process and exactly how it works. Our model is full of fudges and fiddles and workarounds which finance make us build into it to get the numbers right. So you kind of need to know what all those are and kind of why you're doing them. And that slide I mentioned with simplicity and granularity, I think the key thing, another key thing is to understand what the business wants from your model, from your forecasting model. Because if it just wants something really quick and dirty, then you maybe don't need this level of sophistication. We've never found that. They always want the moon on a stick 5 minutes ago. And you need to start by recreating that initial process in Alteryx and get ready. because you're going to uncover loads of mistakes. Well, we certainly did. When we started recreating ours in Alteryx, we uncovered loads of things in our old Cognos model. None of them major, just lots of little things where it had just gone wrong over time. And but yeah, but fortunately for me and my bosses, every time I could say, well, Alteryx is right, and here's why. So that was good. James mentioned earlier that you can take chunks of Alteryx workflows and reuse them in different things. So you know, you can do that. So do it. But also, you don't, because you can create an output from Alteryx at any point. You can take that output and do something different with it. So the first year we did our full model, we just forecasted our student population, and then we dumped that into a different tool to do the finance stuff, which finance we're used to collecting. So you don't need to do it all at once. You probably do need to give yourself a bit of time, because I don't know why everyone laughed when those pictures of those Alteryx workflows were put up there, because they were all very simple, I thought. But it is going to be complicated, and it will take time. I probably wouldn't advise that a forecasting model like this be your first Alteryx project, but you can disagree, because it's going to be based on a lot of your learnings of other stuff you've done, and a combination of all those different things. Jenny forced me to put this part in here. But you know, she didn't. But really, documentation is really important. People talk about documentation at Alteryx as being a self-documenting tool. It kind of is, but probably not enough. And I seem to remember Joe sat there, and the first Alteryx user group I went to in Midlands, in a tiny pub, we sat around a table and talked about documentation, and here we are now. So yeah, it is really important, but it is fun. I think we've all enjoyed building our Alteryx models. You're all here. It's probably because you all love Alteryx, because it is great fun. So that's it. Oh no, it's not. Yeah, sorry, I'm clearly not going to say this out loud, but I did say it once as a joke in one of our sort of practice meetings, and because Jenny's got the controls for the PowerPoint slides, it's now a PowerPoint slide. So yeah, there we go. I'm going to skip on from that one. Just before. If those colleagues who are working in HE, I'm thinking of trying to set up some little meet up tomorrow lunchtime. So keep an eye on your phone if you're using the app, because yeah, something might bounce through. But yeah, that's all we've got to say. Thank you very much. If you have any questions, I think we've got 5 minutes. If anyone has any questions.
What happens if more than one of you want to work on it at the same time? Do you have ways of dealing with that? Do you source save bits of it separately or anything like that? Or do you just have to kind of merge changes back in manual?
Well, we all sit in the same office, so we talked about how we're going to split up the work. There are a couple of big parts which pull all the data together, but as Jenny, I think there were 9 different macros, so there's always something else there's always some stuff that's not being worked on when we pull it all together. And if one person's working on developing the model, someone might be testing other parts of it. So, but yeah, we kind of fudge by that one by just talking to each other, so we know what we're all working on.
Yes, I guess it becomes a bit like a large software project in a way that, you know, the danger is the more people you get working on the same thing, the chances of someone overwriting someone else's changes become greater, I guess. But at the moment, it's contained enough to...
Yes, it is.
For that not to be a problem.
Yeah, although now you've mentioned it, I'm now thinking it might be a problem. But yes.
It's not a problem.
It's not a problem.
No, because you can... Because if you've got partway through a workflow and there's a bit that needs to be changed, you just copy the entire thing and then start working on it somewhere else. But you can also say, okay, we'll give that person those outputs. They can write it. They can write their solution completely separately, and we can just bung it in. Just bring it in
so
a
you would
separate section.
Take the data up to that stage and put it somewhere so that that person could just have that as their input.
Yeah, that's the input for their little bit.
Yeah.
They get their answer, and then we can just bring it straight in. So yeah, you don't really have to have like one version of it that's kind of solid and that's it. And you can just copy paste the whole workflow, and then you've definitely saved that at least.
Thank you for that presentation, because I've got the exact problem, and I'm going to be copying what you've done. With regards to your model, so you've got volume in there and you've got income in there, and I saw you've also got things like retention rates in there. Are all your data inputs fixed files from external sources, or do you allow an element of user manual adjustment and overriding some of those values within Alteryx? How do you have that problem, and how do you handle it?
Thank you. We don't allow anyone. We're control freaks, so we don't allow anyone to do anything. I think there's only really the three of us who touch it, and that's not because we're control freaks. We've built tools out in the past which have allowed schools to adjust things and sort of run scenarios and change. Oh, I think my retention rate for this course should be better than you think it is, but it happens so rarely that we just stopped. It was just a waste of time for us to develop it because there wasn't an interest in running that. Now that may be an issue with that. That's just a Nottingham thing, because I know that other universities do need that ability to allow departments to run scenarios and change things and tweak things and see what would happen if this happened, but no one really at Nottingham cares that much. Or certainly they care enough for us to do it, but not for anyone else, not for them to want to do it. So. Yep. We would add it into the flow at some point, either so another version or another iteration, yeah. That's probably one of the many text inputs when we just say, well, we'll just run this in for now, and then disable it afterwards. So yeah, you're getting some exercise.
So it's a bit of a random one, but do the students have access to Alteryx, and does it feature on any of their courses?
Yeah, I'll answer this one. So, yes, actually. So I used to be a student at the university, and I did GIS. And this year I did a little lecture with some of the students on the GIS course, and I showed them Alteryx. And they had a free trial of Alteryx. They could download a trial of it. And they used it for their project. So yeah, it's being incorporated into student lectures.
Awesome, thank you.
Yeah. Any other questions?
It's kind of pertinent to the question before, the previous one. What's the granularity of your reporting? Like, do you report to each department or to individual professors? When you need to have that dialogue about, is my retention rate right or not, who do you have it with, and how frequently and how much of your time do you have to spend on that aspect of it?
So the granularity of reporting is at stage of course and student type level. So we break every course down to the stage, and we break each stage down to the different home, overseas, full-time, part-time, etc. students. Module data is in there, but we don't report on that. It just feeds into the answer. It's not something we report on. The conversations happen with sort of faculty finance. So the finance team, they have so we have faculty. So each faculty has a dedicated finance person. So we work with them very closely, and they are hooked into the school management process. So each school has a sort of head of. Well, they have a head of school who gets involved, but more likely it's the sort of the director of administration within a school, or director of operations within a school, who will have those conversations with us. And it's all driven by money. So if their money looks right, they're quiet. But if they think they should be getting more money, then they'll shout up. Okay. Thank you very much.